Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today what we're going to be talking about is, well, we're going to be starting a new chapter, chapter number 5, and we're going to be talking about systems of equations. And when we talk about systems of equations, it's important to kind of remember some things that we talked about last year in Algebra 1 so that we can remember what these are and how they work. Well, the first thing really that you need to know about a system of equation is that it's two equations, at least. It could be more, and we're going to get to more this year. But two equations that are connected. Okay, how are they connected? Well, they're on the same graph. They're part of the same system. They hook them together with some brackets or something. But basically, two equations that are connected together. Now, these equations can be whatever. They can be line equations. They can be parabolas. They can be a combination of both. They can be different types of equations, but the idea is that there's two equations that are connected together. The solution of a system of equations is where the lines touch. Now, last year in Algebra 1, we only really got into really one, and that is where you had two straight lines and they touched one time, and that was the answer every time. Now this year we're going to get into some other things. Maybe it can touch multiple times. What if you have two parabolas? Actually, we're going to get into where we're graphing things like, especially in pre-calculus, we're graphing circles and we're graphing waves and different things like that. And so those things can touch a number of different times. Well, let's talk about some different systems of equations or different types. This is on page number 223 in your book, 223. It's called Table A. So if you look there at Table A, I've got it here on the screen. Systems of equations. The first type is an intersecting line, and that's where the lines just cross each other. Okay. In intersecting lines, now systems of equations, I guess this would be better put systems of linear equations. So if you want to put linear in there, linear. All right. So these are the line equations. These are not dealing with the parabolas and other things like that. So intersecting lines, that's the first type. And they just cross each other. They cross each other one time. That's called a consistent system, okay, because the answer is consistent. And then independent. What does independent mean? They're not the same line, basically. They're their own separate lines. The next one's parallel lines. Parallel lines, as you know, they never cross each other. They go in each of them go in the same direction, so they never cross. So that one would be what's called no solution. So if you ever get parallel lines in a system, the answer is no solution. Those are what's called inconsistent, which means there's no solution. And then independent, again, they are not the same line. They're two different lines. Coincident lines. This one happens sometimes. And what happens with coincident lines is they're right on top of each other. All right. Every point is on top of every point. So they cross each other infinitely. They have an infinite number of solutions. Okay. Basically, every point on the line is a solution because it touches the other line, because the other line is right on top of the original line. These are consistent. In other words, they have the same number of solutions. And then they're called dependent because they depend on each other, or they are the exact same line. All right, some good basics for you to remember. Those are all things that we did talk about last year in Algebra 1. The next thing I want to talk about is the three ways to solve these. There are three ways to solve these. Number one, we have graphing. So you could actually put the systems of equations onto a piece of graph paper, and wherever they cross, you would be able to see, oh, there's the solution right there. The next way is by substitution. That's where we solve for one variable. We get one variable by itself, and then we take that and substitute it back into the other equation, and then we solve for it. The last one is elimination, and that's where we try to get one of the variables to cancel. We try to cancel it out with itself. So you probably remember those from last year. Maybe you do, maybe you don't. But we will go ahead and do some of these right now. Let's try Let's try this one. This one's kind of like a warm-up one. Then we'll do that other one that's a little bit harder. This one is on page 230, 224. 224 right at the bottom, example 5.1b. All right, so we want to cancel, or we want to substitute this one. We're not canceling, we're not eliminating, we are substituting. So if I want to substitute, the steps are there on page 124, 224 as well. What we want to do is we want to solve for one of these variables. And I'm just going to tell you, in my opinion, this is the easiest one to solve for. Why? Because it doesn't have a coefficient. So if I take this one, 3x plus y equals 5, and I take the 3x to the other side, I'm going to cancel that, and I'm going to get y equals 5 minus 3x. You could also write it the other way. We could write it in what's called slope-intercept form. So I could write it, instead of that, negative 3x plus 5. That's probably more like you're used to, because that's y equals mx plus b. So if that makes you happy, go ahead and do it like that. It'll also work the other way, no problem. So here's what we're going to do. Now we have y by itself. So now we're going to take the answer, the solution to y, that's the solution to y, and we are going to plug it back into the other equation instead of the letter y. What are we trying to do? We're trying to eliminate the letter y. Why? Because we can't solve it with two variables, okay? So we have to get rid of the one variable. How do we do that? Well, in substitution, we substitute in for it. In elimination, we'll do something a little different. But here we're going to substitute in. So let's go back over here now and let's write this one. So 3x plus, and then we're going to write this. Plus, let's put that in parentheses so we can see what we're doing here. Oh, I forgot my 3. My 3 goes out front. And equals 7. So in essence, all we did was we took that, substituted in for that y. All right, now what we want to do is we want to go ahead and start solving this thing. Well, the first thing that we want to do is follow our order of operations, and we would distribute. So we'll get 3x minus 9x plus 15 equals 7. Go ahead and solve that. Now we're solving for x. We're trying to get x equals. So that's going to give us negative 6x. Subtract 15 from both sides, and we will get equals, what is that, negative 8. All right, and now we can go ahead and divide both sides by 6, and we're going to get x equals, and that's going to be negative negative, so that's going to give us a positive. 8 over 6, we could reduce that. You can really write that either way that you want to. I think I would probably write it like positive. I'd reduce that and go 4 over 3, I think. I'm not sure I would write it like a mixed number. I like improper fractions better in algebra. They're a little easier to work with. So this is going to be our x right here. So we're going to get x, y. This is what we're going for. We want coordinate points. And so our x coordinate point is going to be 4 over 3, comma, and then we're still looking for our y. We don't know what our y is yet. Well, maybe you remember this step from last year. What we want to do now is we want to take this solution, this 4/3, and we want to plug it back into our other equation right here. So 3x plus 3y equals 7. Actually, you know what? Let's plug it back into this one. Let's plug it back into the first one. Technically, it doesn't really matter which one you go into, but I think this one's going to be a little easier for you. So 3x plus y equals 5. So 3x, what's x? 4/3. And then it was plus y equals 5. And then we want to multiply that together. We would, that would cancel. We'd get 4 plus y equals 5. Subtract 4 from both sides. we're going to get y equals 1. Y equals 1. Okay, and so there's our second part to our solution right there, and that would be our solution right there. 4 over 3, comma 1. 4 over 3 is the x point, 1 is the y point. All right, so that's just kind of a reminder, a refresher of how to do this. Let's go ahead and go to now, that was like an Algebra 1 problem. This is an Algebra 2 problem right here, okay? This is the real deal. So now instead of just being a linear equation and just being a line, now we actually have a quadratic, and we're going to get some sort of a parabola or some sort of a because we have x squareds. All right, what do you want to do first on this one? Well, you want to get a variable by itself. So you want to get either your x by itself or your y by itself. Now let me show you a little trick right here with these quadratics. You don't have to solve the quadratic. You can get x squared equals something on these. It'll save you a bunch of time. Now you could go ahead and square root the whole thing out, but you don't want to do that. Make a mess. So it's easier just to get plus y, and we end up with x squared equals 4 plus y. Okay. And now we can take this, and the reason why I'm showing you this is because, look, we got x squared equals, and look, I can plug my x squared equals right into that one. That one's ready to go right there. Okay. And so that works out good. I actually am substituting, I'm actually eliminating that whole x squared term. So that's going to save me some time. All right, so let's go ahead and plug that in. We'll get 4 plus y times y minus 3 squared equals 9. Now we got to solve that thing. How are we going to solve that? Well, the first thing we got to do is follow our order of operations. Always follow order of operations. And so we're going to do that first right there. We need to FOIL that. You should know how to FOIL that at this point. Basically, you just multiply it times itself, and you should get 4 plus y. And then in our FOIL, we're going to get a positive y squared. For the middle term, we're going to get a negative 6y. And then for the last term, we're going to get a positive 9. And that's going to equal 9. Okay, so I just FOILed that. If you don't remember how to FOIL, you need to go back and remember how to FOIL, or you could just go through your steps of FOILing right there. That would be fine too. But you need to remember how to FOIL, and if you can do it shortcut, great. If you can't, go ahead and do it the long way. All right, next, what do we want to do? Combine our like terms. Okay, look at all this craziness going on over here. Let's combine our like terms here. So there's a 4, and there's a 9. That's a C term, so let's keep it kind of over there with the C. We're probably going to have to factor this thing at some point. So combine those, and I'm going to get a positive 13. Here is a y, here is a y. That's going to give us a negative 5y. And there's the next y squared, so y squared. And that is going to equal 9. Move it over to the other side, and you're going to get minus 9, minus 9. And that's going to give you y squared minus 5y plus 4, 0. Now we're in standard form of our quadratic equation. Now we can factor. So that's going to give me y, let's see, it's going to be y minus, and we're going to get 4 and a 1. And that'll give us our 5 there in the middle. And then we set both of those equal to 0, move it over, okay, and we're going to get y equals 4 as one solution. Y equals 1 as the other solution. Now I want you to see something that's interesting. We got 2 y answers. Okay, why did you get 2 y answers? Because we had a quadratic up here in that one. Look right there. That's a quadratic going on. So the y was squared, and as soon as we square something, it always gives us 2 answers. So whatever the exponent is right there, that's how many answers you're going to get. So this is always going to give us 2 answers for y. Notice that we also have two answers right here for x, so we're going to get two answers for the x as well. Now what I would do is I would just go ahead and I would substitute back in those y answers to your original equation. Which original equation? I would go into this one because it's going to be a little easier. So we're going to go x squared equals, actually x squared minus y. Let's x squared minus y is 4 equals 4. Okay. And then the other one would be x squared minus 1 equals 4. And that's just that equation right here, this one right there, with the 4 in there. So now we're just going to work those out, and those are going to give us answers for our x. All right, so we're going to go ahead and put that through, and I'm going to get plus 4 plus 4. X squared equals 8. We have to square root both sides, and that is going to give us x equals plus minus the square root of 8. Okay, so we're not really finished with that. We do need to go ahead and simplify that out. What is that? How do we simplify that? Well, that's going to be x equals plus minus, what comes out of there? 4 times 2. Okay, 4 is the perfect root, and 2, and so what comes out of that? The 2 comes out, plus minus 2 square roots of 2 would be how you reduce the square root of 8. Right, so there's one of our answers, plus minus 2 square roots of 2. Now let's go back to our other one, which is right up here. I'll do this one in a different color. We'll do it in blue. And so I want to add 1 to both sides, and I'm going to get x squared equals 5. We're going to square root both of those, and I'm going to get x equals plus minus the square root of 5. We cannot simplify out the square root of 5, and so that is the answer right there. Now let me show you how to write this, because it's a little bit confusing how to write this. Because look, here's what's going on. Positive 2 square roots of 2 is an answer. Negative 2 square roots of an answer. Square root of 5 positive is an answer. Square root of 5 negative is an answer. All right, so we got lots of different answers going on here. And we're just going to go ahead and plug into those. Now, which ones go with which? Well, look, the negative 1 goes with the plus minus 5. So you're going to have positive square root of 5, comma, 1. Okay? You're also now going to have negative square root of 5. Okay, so that's one set of answers. Because why? Because the 1 in the y gave us those answers in the x. Now, what are we going to get for the other one, the other y? What was the other y answer? It was 4. And so the 4 ones give us the plus minus 2. So one of them is going to be a positive 2 square roots of 2, comma 4. And then the other one is going to be the negative 2 square root of 2, comma 4. So this one actually gives us 4 answers. You should be able to recognize why it gave us 4 answers. All right, so if we go back to the front, we're going to see that the x squared is going to give us 2 answers. And the y squared is also going to give us 2 answers. And so we're going to get a total of 4 answers on that one. All right, so there you go. That is the 4 places that this would cross. Now, what does this look like real quick before I end the video? What does this look like on a graph? Well, it looks something like this. So you have a parabola, and then you have another parabola, and maybe your other parabola is coming in at another angle, okay? And so you're going to have 1 crossing point, 2 crossing points, 3 crossing points, 4 crossing points. Now that's not perfect. I just threw some random stuff down there. But that's the idea. The idea is that you have one parabola going up, one parabola going sideways, and they're going to cross 4 different times. And again, you can have a number of different situations here. What if I have one parabola and one straight line? Well, then I'm going to have 2 answers. I'm going to have across there and across there. And so you can have different things, different answers there, but if you have 2 parabolas, especially if one is going this way because of that y, you might end up, and here's another thing, you might end up with no solutions because that one doesn't even cross at all. There's 2 parabolas there, but they don't cross each other. So there's some different types of situations that you can run into with parabolas, just like different types of situations that you can run into with line, like, you know, parallel or coincident lines where they're right on top of each other, stuff like that. Okay? All right, lots of stuff in there. It's Algebra 2. It's action-packed, lots of good stuff to learn. And so work through those, try to figure those out. If you have any trouble, rewind that video and take a look at it. See you later. Bye-bye.